Yes. Okay. All right. People watching this video, you guys have a paper that looks like this, although yours is not in color. I'm sorry. And we started talking about hypothesis testing, and I'm like, because it's a Friday, let's just flip over to this backside and let me just run through and show you how this hypothesis testing thing works, right? So I'm going to separate this into 3 pieces, okay? And what we're going to do is I just gave you this example right here, and I'm going to explain what this means. So write that guy down on the first column of the 3 pieces. We're going to go through and do all of the hypothesis steps right here, and we're going to come up with a conclusion, okay? That's what we've got. All right, so write that down. We surveyed 100 people, 54 of those 100 people have blue eyes, okay? That would be 54% blue-eyed, right? Okay, but is that just for my sample? Maybe I sampled everybody from the same family, right? And got biased results. So is it fair for me to conclude that if I surveyed everybody, that would actually be a majority that have blue eyes? I don't know. We've got to test that, okay? So that's what we are trying to determine. Now, we did not talk yesterday about this, and this is, I call him the fish value because that's what he is. He is an alpha value, ALPHA. An alpha value, and he is kind of like saying what your confidence interval is, okay? So this is like 5% right here, and we're going to talk about what that means, all right? So we'll get to that, but they have to give you an alpha value. It's like telling you whether it's 90%, 95%, 99%, that type of thing, okay? So we'll talk about this, all right? Good? Okay, they're going to give you this information, and that's all they give you. And they just say, do the hypothesis test to tell me whether that means I can conclude that a majority of all people have blue eyes, right? Because according to my data, 54 out of 100, that is a majority, right? But would that be true for all groups, like all people, right? Okay, so step number 1. Do you guys like steps? Like if I lay it out in steps, step number 1? Step number 1, you want to do your hypotheses, okay? So you have H0 and H1. Sometimes they would call that HA for alternative hypothesis. So do those and put a colon next to each one, okay? You, sir. Get a paper, write this down. Help me help you. Okay, H0, H1. All right, we're talking about percent here, okay? So I'm going to talk about everything in terms of P, all right? Now, we're talking about majority, and they didn't say anything besides majority, but majority means 50%, so majority is 0.5, all right? Okay? Now, majority would be like greater than 50%, but the top hypotheses I told you yesterday you always say is, do you remember? Equal. Somebody said that. Equal, okay? So we're going to say equal to 50%, right? Or equal to 0.5. Then I want to see, okay, maybe it's not equal, maybe it's actually greater than 0.5 because majority would be more than 0.5, okay? That's step number 1. Which one am I claiming? The top one or the bottom one?
Claiming the bottom.
We're claiming the bottom one. Okay, we're claiming that the bottom one is true. Yeah? All right, second step. What we're going to do next is we're going to fill out a bell curve. All right? Here's what my bell curve looks like. Now, we're looking for greater than, okay? So if like the average lives here, I want to know if my value is significantly higher or greater than, right? So I'm going to shade the right tail only of my bell curve. Do you see why I shade the right tail only? This guy tells me where I shade, right? If I'm doing greater than, that's what he looks like. Got it? Okay, there's where he lives. All right. Next, I guess I'm gonna label some things. No, I'm not gonna label some things. Step number 3, let's do the value of what's called the test statistic value. Okay, I wanna do the value of the test statistic, okay? And the formula for that is Z equals. It was on like the top of, if you flip this page over, this formula is right here. Test statistic value, we're gonna use that top one because we are doing a proportion for this section, right? Then the next 2 sections, we talk about mean. The next section, we talk about standard deviation. So for this section, we're going to use that formula, all right? Blah, 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 blah. I'm going to recopy him right here. Here's what you need for the formula. Formula, P hat minus P over the square root of P Q over N. Okay, you don't need to memorize him, but you'll do him often enough probably that you will maybe have him memorized whether you want to or not. Okay, so there's that. Am I going too fast? Are we doing okay?
Minus P. Yeah, minus P.
P hat minus P, yep. Okay. All right, so we got to figure out what our variables are. Maybe we should label those over here. So We need to know what P hat is. We need to know what P is. We need to know what Q is. We need to know what N is. Okay, according to my information up above here. All right, so let's pull that stuff out. 100 people. I'm just going through my paragraph again. 100 people, that's N. That sounds good. 54 had blue eyes. You're close.
They're both.
It's going to be P hat, but it's going to be 54 over 100, right? So 0.54 is my P hat, okay? Now, we don't have to do Q hat, right? Just P and Q, got it? So we don't have to do like 40.46. That's not Q hat. We don't need Q hat, right? What is P in this case? We have P hat. What's P?
Still 0.5.
Yeah, right here. Look right here. P equals 0.5. That's what we're testing against, right? We're testing against majority, which is 0.5. So then what's Q? 0.5. All right, let's plug those in and let's find our test statistic Z guy, right? Okay. All right, so P hat is 0.54 minus 0.5. And I just made up this example. He is on the back side of this sheet. Okay, we're going to do another example here in the middle. We'll fill out this middle column, and then you'll maybe get it a little bit better. Okay, so 0.54, 0.5, the square root of PQ, so 0.5 over 100, right? And we're going to do all that stuff, and we're going to find what our test statistic value is, and then we don't have much more to do. Oh boy, I think he's on his last leg. Nope.
You know how fast Trevin and Hallie are right now?
I got 0.8 for a test statistic value, okay? All right, if you want to think about that in terms of Z, this would mean like a Z score of 0.8. That's pretty darn close to this, at like 0 lives here, 1 lives here, 2 lives here, blah, 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 wherever at, right? 0.08, okay? If I were to guess, I'm going to guess 0.08 is going to live here versus here, right? 0.08 is probably in the closer to range. Does that make sense? Okay, we'll get to that. All right, but you see where I got 0.08 or 0.8, 0.8. Round to 2 decimal places, I guess. So maybe we go 0.80, whatever, okay? Got it? That is that. That's my value of my test statistic. Now, step number 4. Okay? Find where Z lives. Okay? All right, there's 2 ways of finding this. I'm going to do what's called the critical value method. Okay, there's another method, and it's called the p-value method, but I'll teach you that later. I'm not going to do that today. The critical value method. All right, we got to find where Z lives. Okay, so here's the deal. I know that Z is 0.8. I know that 0 lives here, and I need to figure out what this cutoff mark is. If I knew where this cutoff mark was, I would know whether 0.8 lives here or 0.8 lives there. I'm going to guess he lives over here, right? But I need to know what this cut mark is right here. Like, where does that cut off at? Okay, and here is what this means. When you have a significance level of 0.05, right? 0.05 would be 5%. What that means is my significance level, your alpha level is your level of significance. That means 5% of here, right? 0.05 or 5%, right? That's my level of significantly high if it's in that top 5%. All right, now, how does that help me find a Z? Like, what is the Z that corresponds to that? Okay, a lot of people think that 5% means 95% is what I'm going to look up to find Z, but that's not right. Okay? The way that this works is that if 5% lives there, I want to know the middle chunk right here. So you kind of have to think about it in terms of like there's an imaginary 5% over here. So the number I'm going to look up on the Z chart is 90%. Why 90%? Because 90% would be the middle that's not considered significant. Does that make sense? 5%, if it's beyond in that top 5%, it's considered significantly high. It's also significantly low if it's in the bottom 5%, although we're not looking at that, right? Like, because we're only interested in the top 5%, okay? So we're looking at 90%. Now it's very easy from here. Go to your Z chart, like the bottom corner, 90% has a z-score of what? Like 1.645. Is that true?
Yeah.
Okay, so if z is 1.645, that tells me where that cutoff mark is, right? Are we confused?
So we found,
So it's always gonna be that unless we have a high and a low one?
Maybe. We'll talk about that here in a second. Actually, let's talk about it right now. So let's say instead my alpha level was 0.10. I was going to originally make him 10%. That means 10% lives here, but then 10% lives here. So what number are you looking up on the chart?
80.
Now I'm looking up 80%.
Okay.
Okay? Now we'll get to the point where if we have two tails and you have an alpha level of 10%, right? If you have two tails that are shaded, which we'll get to that, you're going to put 5% here and 5% here. You have to split this alpha level. So that is still 90%. We'll get to that. Okay, that's a little confusing. But in a nutshell, that's how that works, all right? So your significant level tells you what number you have to look up, right? Blah, I don't know why he's not erasing. Okay, anyway, so there's that. Let me erase these guys. Un momento, por favor. Okay. I should have just undone him. Whatever. Okay, all right, good? So 1.645. Now I can just draw my conclusion. So this is step number, oh wait, we got to find where z lives. Where does z live? If 1.645 is my cutoff mark, where does my z live that I found? My test value, where does he live? Where does 0.8 live in relationship to 1.645? If here is 0, 1. He lives over here, right? 0.8 will live there for a z-score, right? Okay, now, I figured out where he lives. Now, step 5, I have to draw a conclusion. Draw a conclusion. Okay, now here's the deal. When you draw a conclusion, we're going to look at this stuff right here. This is the last part. This is the conclusion part, okay? We know that 0.8, my value lives here, right? So does that mean I'm going to say that he's greater than, or am I going to say that he's equal to 0.5? If 0.8 lives here, does that mean he is in the significance range where he is greater than, or is he equal to 0.5? Where does he live?
9.
It would be significantly greater than 0.5 if he lived in this significant region, right? If he's elevated above, right? Like this is considered significantly greater than 0.5, right? Like he has to live in there in order to be significantly larger, right? So, according to this is not true because he does live in the middle region, right?
Wait,
So what they're saying here is that our number of 54% is close enough to 50% to say that that's exactly 50%. It's not greater than 50%. It's not elevated beyond 50% enough to say that it's significantly more. Confusion? We will do more of these so that you will see that. What do you need? Yes. Okay? So in order for him to live over here, like if he lives over here, then we are going to say that he is in greater than land, right? So, according to this, it says, determine if the majority of all people have blue eyes. Do the majority of all people have blue eyes?
no.
No. Majority of people do not have blue eyes. It is right around 50%. It's not elevated beyond 50%, it's right around 50%. It's close enough to 50% to say that it is 50% exactly, which is not a majority, because it might be 48% in the next sample that I have, right? So it's not elevated enough beyond 50% to say that that's a majority. Got it? Whoop. What time do we get out of here? We have lots of time, don't we? A few minutes, please. 6:23. All right, we're gonna do one more. One more column. This will go faster this time because we know what we're doing. Maybe, hopefully. Okay, middle column. I'm gonna make him just slightly different. What should we talk about now?
We should still survey 100 people.
Yeah, I like that. Okay. Survey. 100 people.
turn the prom paperwork in.
Survey 100 people. 27 turned in paperwork. Turned in prom paperwork.
Well, I was going to turn mine in.
I'm just
Have all of
kidding.
it,
I'm
so-
just kidding. It's fine. It's fine. 27 out of the 100 turned in prom paperwork. Conduct hypothesis test with an alpha value of 0.10 to determine if we can say less than half. Turned in. Okay? Now,
Hold on.
according to this, did less than half turn them in?
No. Yes.
Yes,
Yes.
only 27 out of 100, right? But is that fair for me to say that by the deadline every year, less than half will have them turned in? I don't know. Maybe we just have a terrible year where all of you guys are just lazy. I don't know. This is not real data, by the way. But anyway, so, and you're not lazy if you don't turn in prom paperwork. I'm just saying. Whatever. It's fine. It's fine. Okay. I know. Maybe. Whatever. If you can say less than half, turn it in. Okay, so here's my data. All right. Step number one, we got to do our hypotheses. So H naught, H1. Okay. We're still talking about P and P. Where we're talking about less than half. Okay. So P is less than half. P is less than 0.5. Where does the less than 0.5 go? H1, right? Because the top one is always equal to, okay, we are claiming less than half though, so we are claiming the bottom one. So similar to the first one, our claim is still the bottom one, all right? Now, second thing we're going to do is we're going to put our bell curve in there, except this time we're going to shade the left side, the bottom side, right? Okay, less than half, that means we're looking at a lower than. Less than half a bottom side, got it? All right, less than half turned it in, there we go. Okay, all right, step number 3. Oh, maybe let's go ahead and do this. Let's go ahead and do this. Let's figure out what our z-score is, like where our cutoff mark is, before we even determine. Now that we know what we're looking for, okay? Our alpha value is 10%, right? That means 10% goes here. So what percent are you looking up on the chart? 80, because you have like an imaginary 10% over here. Like basically 80% of the data is going to be in not significantly high or low, right? 80% is the number you're looking up on the chart. If you look up 80%, it is... Do we have an 80%? Is it 2.33 or something like that? No.
1.28.
1.28. Perfect. I can't math. Okay, now, since it's on the negative end, though, we have negative 1.28, right? And if you want to think about it, positive 1.28 lives there, but we don't really have a mark for him because we're only looking at the negative side, right? So that's what he would look like, okay? All right, what do we do in step 3?
We plug everything in.
We want the test value or test statistic, right? Test value. Z equals P hat minus P over the square root of P Q over N. Is it helpful to label out what all our things are? P hat. What's P hat? 0.27, right? Because 27 out of 100 or 0.27, right? Okay. P? PQ is 0.5, 0.5. It won't always be 0.5 and 0.5, by the way.
Is that if
0.5 and 0.5 would just be majority. They might say, let's test to see if 30% of all people turn in paperwork. Then it would be 30% and 70%. Okay, so we'll get to that.
We're not gonna make
N is 100. Okay, so we're going to plug stuff in. 0.27 minus 0.5 all over the square root of 0.5, 0.5 over 100.
Thank you.
0.27 minus 0.5. That did not do what I wanted it to. Divided by the square root of 0.5 times 0.5 divided by 100. Okay, here's my z value. Are you ready?
Hold on. Sure, how many?
Negative 4.6. Woo! That's a pretty extreme z-score. Right? Okay, step number 4, let's find where he lives. Where live? Okay, we looked at the critical value. My cut mark is negative 1.28. Where does negative 4.6 live? Woo, all the way over here. So now let's go with our conclusion. Are we going to conclude that it's equal to 0.5 or it is significantly less than 0.5? Right? That's in the less than area, right? It is in the shaded region. It's in the less than area, right? Okay. All right. Now I'm going to use some different verbiage to talk about what our conclusion is. So our conclusion is, ready? We're circling this one. We're crossing this one off. So what we are doing is we are rejecting circle the less than one, right? Because it is less than. It's in the less than region, right? And we cross off the top one.
Before we did the opposite, right? Yeah.
The one before that, we do the opposite. Okay, so we are rejecting the null hypothesis. Our claim is true or false?
True.
True. Less than half. Turn in paperwork. So I can conclude that maybe next year I can anticipate that less than half will turn in their paperwork. Right? Again, this is made up data, but there you go. Okay? So we're rejecting the null hypothesis that it was equal to 50%. We are concluding that it was in fact less than 50% of all people turning in their prom paperwork. Got it? Yes? Okay? So our claim is true. Do you see how that works? Because 27 out of 100 is significantly less than 50%, we can conclude that it is significantly less than 50%, right? Based upon the data. All right? Now, you guys have one more column, which we're not going to do today, but to the next column, do you want to take a guess what we're doing in the next column? Two tails, all right? And that's a little bit different than the left and the right, so we'll leave it there, all right? Beautiful. And my right column is like the skinniest one ever, so hopefully we can.
Bruce a question?
Okay. All right. Goodbye, people watching this video.